Hello everyone and welcome back to video 40 in this set of videos. It was originally preparing some lecture notes and estimating things, and we're getting very near the end. Just a few steps left to do. One of the next big obvious ones is to make the alien move. But before we do that, I want to make a slight change. This is 40 videos into to the set, so um, there's been a whole lot going on. A bit much to talk about so far. And I'm going to come over to this input map. And I originally tried to put the hitting the alien with the shift key and just stuck with this space as the jump for default. And I kept trying to hit space for the hit button. So I want to change that. I'm going to come over here and add a new control for this. And I'm going to switch that to the shift key. And then remove the space. How do I remove the space? Oh, then remove the space bar on jump, because hitting is our main action anyway. I'll come down here and use space bar for hitting. And if you notice yourself doing things like that, like you think some controls are going to work, and then catch yourself constantly doing a different one, go ahead and make the change, because that means other people's intuition are probably going to go for that other control too. So I wanted to start with that. Now let's make our character move. Okay, and there's a couple different ways we can handle this. There's a powerful feature built into all of our game engines called a navigation mesh, and I considered using that in this tutorial to kind of go over it. But a couple things about that is it is something somebody else completely made up, so there's not logic to fill out. You have to actually memorize all of the names somebody else used, which usually amounts to um, checking the documentation and memorize all the functions that they put into that. And they're very, very useful. But another thing, I guess it's like another one of the tips that I found over the years is if you put your navigation mesh in the rough draft, when you come back and start polishing that up into a nicer version, you're pretty much going to have to delete and recreate the navigation mesh, maybe several times. So over the years, I've learned that kind of developed the habit that I do not put a navigation mesh in the rough draft unless it's absolutely necessary. Um, One of the things we'll need is, even once we get the navigation mesh, we still have to choose direction and stuff. So I was just going to do the choose direction part. Um, right. It's going to basically um, choose a to turn left, turn right, wander in a random direction, maybe stand still, or maybe move towards the character. So it'll do one of those things, and that would have to be there even with the navigation mesh there. And um, navigation meshes are take a minute to get into, but and it is a long list of things to memorize because it's an object created by somebody else. We can't control the logic in that except for the direction we go. So I wanted to look at the direction on that and set it up in a way that will still work when we add a navigation mesh later. And for a tip on game engines, because all of them have the navigation meshes, they're very, very useful. We would just tell our, uh, basically tell the computer that this landscape is spots it can walk on, the trees and the water are not spots it can walk on, and then it would find its own route around. And we would still have to kind of pick directions and stuff. And um, there's a few other functions in there, very powerful tools worth looking into, but these videos are sort of an introduction, so I wanted to go over the logic, and it's something that would still apply if we did the navigation mesh. So we need to get our character moving. So let's jump into the script and start doing that. So we jumped into the script. When we first created this, we used that default one that had some movement, but then we deleted all the movements. So I want to copy some of that back in from the player script. So I'm just going to start over here and start going down with the things I know I'm going to need. So I know I'm going to need gravity, so I'm going to bring gravity over um, and just paste that in here somewhere. And then the gravity was working because of uh, this function right here. So I'm going to copy that over to the alien script. Um, I'm going to paste it before the is active section so that we disable our character, which happens when we hit it and it goes flying off to the side. Gravity will still kind of apply, so it'll still have it'll still kind of look appropriately there. And this leads into something that I like to do. If we come back over to 3D and select that alien we have and zoom in on him, for testing, we set him right on the ground. I always like to start things just a little above the ground, and that way, whenever the game starts running, gravity in the first, like just barely above the ground, so in the first frame of the game, gravity pulls it down and positions it correctly. I did that with my character earlier. I can't remember if we mentioned that or not, but in the first frame of the game, it's just barely above the ground, so gravity will pull it down, and by the time our eyes register it, it will be standing in the correct spot. So that'll get gravity pulling it down and keeping it on the ground. So then we just need to worry about the X and Z position, which we can copy our direction from here. And we even use the same parameter names in the animation tree. I was thinking ahead to this when I did that. I probably should have explicitly stated it back then, but I was thinking ahead when I used those same parameter names in the animation tree so that this would just copy and paste over. So I'll do this. If it's not flipping, then it's going to choose a direction. Oh, wait, that's not where that goes. That does need to go in the active part. It only needs to choose a direction if it's active. So it doesn't like this Z right here. There's no Z. Z is not declared. That was the direction we chose, but I'm going to change that line anyway. Also says speed's not identified, so I need to create speed. Come up here, create a new variable, call it speed. It's going to be floating point data. I'll start it at 3.0, but we might need to look for something, so export it so we can access it in the inspector and then change it while the game's running so we can find a good speed. And then that direction one, that's going to change randomly. So instead of having controls and doing it, I want to take that line out and just create a global variable called direction, which will be vector3 data. And I'll start it at vector3.0. That's just a special way to say vector3 of 0, 0, 0. So it starts blank, and then we're ready to, we'll set up a selection structure to decide which way it goes. And we would need a similar selection structure with a navigation mesh too. Actually, the same thing would be here, except for one function, we'll use a basic one instead of the one built into the navigation mesh. Everything else here would still apply to navigation mesh, so I might make a video for that. But my general tip is, unless you absolutely have to have a navigation mesh in the first draft and the rough draft, save that for later and just get some basic movement and stuff in the rough draft. Because when you come back and start polishing the game, you're going to end up deleting and recreating your navigation mesh several times. So really, that is for something you don't want to include until the game's a little more polished. So all we have to do is set up what the direction vector is going to be for the X and the Y, and then it'll move. And if the direction vector is the 0 vector, it's going to stay idle. So how do we decide when to move and when not to move? And at least for now, and actually what would move into the navigation mesh is I was thinking just set a timer to go 4.5, 5 seconds, something like that, and then it'll randomly choose a direction. So we need a timer to go with this. I'll call it change. It's going to be timer sort of data. And we've seen the syntax for a new timer a few times. And I will just copy one of these and put in here. Be change. Copy that and replace all this where I copied over. And this will call a function called change direction, which I'm going to put on the clipboard and need to go do that. But one thing we need to do while we're here in the ready function is our direction change is going to be based on random numbers. And in most of our game engines, the default is a little bit different than the random you would use in your normal programming languages. The random will always start with the same seed. When we're doing business application sort of programming, if we want it to have the same seed, there's not really random in computers. It's a very predictable number, so that if we start with the same value feeding through this algorithm, it's just the results are scattered around enough that it seems random. But if we start with the same number, we'll get the same result every time. And in business applications, the default is to change up the value that it starts with. But for game engines, the default is actually to give it the same seed every time, so we get the same random every time. So it's the opposite of what you're probably used to in other programming languages. Whoops, not paste. So to do that in Godot, there's similar syntax in Unity and Unreal and all our other major game engines. When we first start our game, we want to call this randomize function, and that gives us a different seed every time. So we end up with something that's actually seems random. It's not the same route it takes every time. All right, now I'm going to come down here and create that function that actually decides how we move. Change direction, and we'll just pick a random direction to go in. Or maybe randomly stand still. Maybe not quite randomly, because I do like to have some sort of basis on it. I'll put it in the name here. So instead of random direction, I'm going to call it objective. What is our objective this time? And that's going to be based off basically rough probabilities of what I expect to happen in the game. So instead of dealing with a floating point number, I'm just going to make it an integer. This is a built-in function to Godot. Range gives us a random integer somewhere between 0 and 100. So a probability. 0%. Actually, I guess we could probably go to 1 to 100. Very, very low probability. We don't need the not going to happen chances. Or absolute certainty would be the probability and what's going to happen. But just that range of 100% that could happen. And then I like to split that up. If it helps, like if you're a big D&D player, a lot of people that write programs also play a lot of D&D. Think of it like a dice. Maybe do a couple die. Do like 1 to 20, 0 to 19 or 1 to 20, and there's your 20-sided die, D20 or your D3 or D4, and think about rolling those dice. My biggest background is in pure mathematics, so I've had a lot of probability classes in grad studies and things like that. So I think of it best this way, but think of like the D&D dice and break up your probabilities that way, and then just set up your selection structure. So maybe let's say 15% probability will stand still. So if the objective is less than 15, then we will set direction equal to that vector 3.0. Whoops, not vector 4. Vector 3.0, which is 0, 0, 0. 0 in every direction, which basically means it's not going to move. Then we need some other probabilities. Maybe if it's not less than 15, it's less than 45. So we can think of that as a 30% chance that it's going to turn left. And there's no clear indication, so I'm going to add a comment here so I don't forget about it. So rotation, actually, we can do some copy and paste. Making typos is a human trait, so it's always good to let the computer do the typing as much as possible. We already have turn left. We already have the logic of how to turn left, copy, paste it in. Then we can do the same thing for right. If objective is less than 75, so another 30% chance we're going to turn right. And I can copy it from the other, whoops. Oh, Paste. Nope. Well, I don't know how that ended up on my clipboard. I was going to paste the same thing again, but I'll just go back over and copy the turn right option. Paste that in. So there's turn left, turn right. Otherwise, the last 25%, well, let's just make a V-line for the player. Target equals our player, so we'll need a reference to the player. I'll scroll back up to the top and then click and drag just like we've done before while holding control. Whoops, I forgot to hold control. I said hold control, but I didn't hold control when I said it. Wait, what's that? Did I hit the wrong button? So click and drag that in. There we go. I guess I could have just typed all of that. And we know what type of data that is. I'm just going to add the infer operation there to make sure it stays as a strictly typed language, because strictly typed languages are a little bit faster. So our target is going to be the player dot position. And then there's this useful little thing built into Godot, but it's actually, we have the same thing, and it's the same words, but a different syntax. Like in Unity, it's look at in Pascal case, so the L and the A are capitalized and the words are jammed together. In Unreal, it's look at in Camel case, so the L is lowercase. There's no underscore. The words just jammed together, and the A is uppercase. So basically, we have that function everywhere, but it is unique to our game engine. So we'll look at it, and then I want to do what our player does to move. Remember how we've found forward every time by we just set a new basis every time, a new starting point, and multiply that by this. Multiply that by the direction the control said to go in. So we can do basically the same thing here. We can paste that in, and well, we don't have a Z thing, so I'm just going to make that 1. So that gets us our sparks to look at. Oh, this delta's highlighted. We could just pass delta in when we call this, but I'm just going to ignore that and, at least for now, make the alien will do the entire turn at once. In later polished versions, when the navigation mesh is there, it will that can polish off those turns, so we wouldn't even have to worry about it then. So this part we would still do even with a navigation mesh, which I might make a video to show, but those get complicated, and those somebody else just made a tool to use, so it's a whole lot of just looking up the names of the functions that somebody else made and asking for a particular one. So there's not really a whole lot to show with those except to add it to your hierarchy and check the documentation for the name of the function you need from it in all of our game engines. But we would still decide how our character was moving around the mesh with something like this. A 15% chance we stand still, 30% chance we turn left, 30% chance we turn right, and then the last 25% chance is that we make a V-line straight for the character. There's something missing, but I want to go ahead and run this so we can see something. If we turn it, we can see our aliens idling. Oh, actually, we have to start that, don't we? So we did all that, and then we need change start. Forgot to copy that over. And before we do that, I want to call that at least once. That way we have a direction right to begin with. And there's a line of code I didn't type in, but I wanted to show what would happen. In class, a lot of times I like to show what would go wrong. Why is he just idling? He should be doing something other than idling. Oh, yeah, then we have our direction, multiply all that out, and Oh, I forgot something here. Um, if we turn left, we still want to move in the Z direction. So we'll set our Z direction to 1 after we do that turn. So now in every branch, we do something with our direction. And then when we get up to the physics process, the direction is what determines if we're standing still or moving. That if it's a 0 vector, we jump to the else block and go to the idle animation. But if there's something in direction in every one of our if else blocks, we want to make sure that happens. Hopefully that logic all makes sense. I'm still missing the line of code that I wanted to show what goes wrong if we forget it. So you can see he went to a different direction and went to the walking animation, but he's not actually moving. And that's because, well, it's over here in the player script. Down here at the very bottom, there's this method move and slide. That's what actually applies all of the movements. So all of the logic is just setting things up, and then this actually runs the stuff that we just set up. So I'll come down, I'll do it here. So after we do all of our movements, then we want to call that move and slide method. Now we should move in different directions. So we turn around, we see him going, oh, right towards the edge. I was going to say something about this anyway. Right now, without a navigation mesh, the character might just walk right off the edge, which I think he's going to do. So we didn't get a chance to see him change direction after, how long was that set? Change direction, should probably be like 4 seconds or something. I'll put 4.5 seconds. I'll go ahead and put this in, that thing. If they walk off the edge, I'm just not going to worry about it for now. Position.y is less than 0. If he starts falling and goes past the origin, then we can do self.queueFree. We'll remove it from memory if he goes past the origin. Because here in the next video, we'll set up a spawn point so that it just spits out lots and lots of several spawn points, so the game just starts spitting out aliens. So the navigation mesh in later polished versions of the game will handle not walking off the edge, but for now we'll just punt that down the road until we're ready to put a navigation mesh in here. Because in the next video we'll be adding a spawn point that just starts spitting out aliens, so it won't matter if one of them walks off the edge of the scene, of the world. So he's standing still, and he turns, and chose to still continue to stand still. 3, 4. Something seems wrong there. It kind of looks like he only did that one time. Oh, I bet I know what it is. Oh, yep. Our timer only ran one time, so let's set that to false so that the timer keeps running, and every 4.5 seconds he changes direction. Hopefully that worked, because this is the very upper limit of what I wanted these to have. It's not changing direction. Or I just said that completely wrong. I'm getting to the limit of the time I wanted these videos to be. So I think the clock's okay. Oh, we already have a direction variable. We don't need to declare a new one. Maybe that's what it was. Give this another try, and hopefully it's finished now, because this is what I wanted to get in here. Okay, there we go. Starts walking off, and after a few seconds changes direction, and we just have that random movement, and looks like that's going to walk off the world again. But before long, we'll have several spawn points, like one up here on the hill, a couple over there. Oh, the alien ship should probably be in the sky there somewhere. We'll need to do that. But We'll have a few spawn points, many of which will be further away from the thing. And in a later polished version, when it's more useful to put the navigation mesh in, I'll do that. And that's another one of those tips is don't put a navigation mesh in your rough draft unless you absolutely cannot go without it, because you're going to end up deleting it and or doing so much editing, and it will cause problems to put a polished feature like that, a final version feature like that in an early draft of your game. So put that off, but do set up the movements you will use when you get to a navigation mesh later if you're going to use that. And you might want to come up with a more clever way than just punting the problem of walking off the world. There's lots of solutions for that. Otherwise, I'll see you in the next video, and we'll set up a bunch of spawn points so that we have lots of aliens doing that random movement, standing still, turning left, turning right, or making a V-line for the character. And gives us something to do in the game. Makes the game a little more challenging than what it was for the debugging states. I'll see you in the next video.